All right. So hello, I'm Josh Wisenbaker, and I'm going to talk to you today about a transition that I made myself over what seemed like far too long, the amount of time it took, which was changing over from being a sysadmin to being into software engineering, what software engineering means and to different people, things like that. We're going to take a little trip down memory lane for part of this. We'll see some stuff about my past. We'll see some stuff about the history of computer science, history of computer engineering, history of myself at Apple and other places, history of Orchard and Grove. I'm going to talk about some real-world train wrecks I've walked into that would just stun anybody that sees them. And then we're going to talk about what to take away from this. If you're looking to make a transition like that, if you're thinking you want to change from being a sysadmin or a DevOps kind of person into more software development, it's not for everybody, but it is for a lot of us. And so first of all, why would you want to listen to me, right? So everyone used to know me. I was internet famous 15 years ago, and then I went to Apple and had to vanish, right? So I'm Josh. Hello, everybody. I am head of engineering at Orchard and Grove, which essentially means I get to yell at Joel about his code and the things he does with his code. There's only two of us doing full-time dev work at Orchard and Grove. We make a bunch of different products there. We make the Nomad products. We make Nomad, Nomad Pro, Nomad PK init. We make Nomad Login for AD and also for Okta. So we've got a bunch of irons in the fire. This is a lot of software development on active products that are being used by hundreds of thousands of people around the world for the open source ones, and tens of thousands of people around the world for the non-open source ones that are per seat licensed. Those always feel a bit edgier because those people are paying for that software, right? There's a direct license locked sort of thing. And so we have to make sure we have a good system to be able to get stuff up and running and to make sure people can use the products and the products meet the needs of them. A lot of that, if you just kind of fly at it, falls apart. So first of all, everyone remembers this from Henry Hill, right? Everyone, as far back as I can remember, always wanted to be a programmer. So that was pretty true for me. This 1984 was like 1984. If anyone picked me out on that, this is my 5th grade class. Second row. No, not second row. There I am. I'm at the bottom front stage right, or stage left, bottom front. So this was in Matthews, North Carolina. And I had computers, and then some of you were around in the early 80s as children. Some of you were not. I've made that painfully clear. We had a call the other day with a customer who told us that he used to read AFP 548 when he was in the 6th grade to help with the computer labs at school, to which Joel and I both had to take a nap. So it can happen. The first stuff I ever wrote that was code was on a Timex Sinclair, which is the American version of the BBC Sinclair. It was this was it. That was the whole computer, right? White text, white screen, black text. You couldn't do a lot with it. You had no storage, you had nothing. You had to type it all in and make it run, and it was hard. And then after that, I destroyed my parents' ability to be surprised, where after bugging them for 10 years of my life, every year of my life, to get a go-kart. Can I have a go-kart? Can I have a go-kart? Want a go-kart? Can I get a go-kart? Can I get a go-kart? 10th birthday comes around and they say, all right, you want a go-kart or you want to get a computer? And I said, computer. And then when they woke up from being shocked and passing out on the floor, we bought a Commodore 64, still the most popular computer ever sold. We got it at Richway, which was a department store. And I learned a bit of Commodore Basic. Commodore Basic was pretty easy, but programming, again, is hard. It's just this text thing. You got to type it all in. You have to save it to a cassette tape. You have to do all this. If you do anything advanced, it's all assembly language. The language I had the most success in was Logo on the Apple IIs at school, right? You remember, people don't remember this a lot, but Apples used to have 2 Apple keys. There was an open Apple and a closed Apple, right? And you would do a certain key chord at startup, and it would put the machine into this Logo mode. And then you could program stuff. And I wrote some little animations and other stuff in Logo Logo still exists today, surprisingly enough. You can use Logo today on your iOS devices. There are logo interpreters for iPads and things like that, and in a web browser. In 1984, it took a whole computer to run it, and now it runs in 18 lines of JavaScript or something like that, or on your iPad, but it was there as well. Programming in the early 80s was hard. To do anything beyond basic line 10, print Josh is cool, line 20, go to 10, and let it run until you hit the print break, the run stop key. To do anything more than that required peeks and pokes, direct memory access, all this stuff. Remember, these computers, the entire computers had 64K of memory, right? Kilobytes. They did not have anything. There was no room to do anything. And so I kind of flamed out on the whole programming thing, right? My backup plan did not work. I'm not an astronaut, as you can see, so I had to figure something else out that I would do with my time. So around when I went to university, I kind of threw myself into Mac system administration and things like that. So I graduated college. I worked at an Apple VAR. I worked at Computer Tree Technologies, which is in North Carolina. I also worked for a couple of big companies. I worked for Lowe's Home Improvement as the Mac sysadmin there, and I did a lot of that. I did a lot of speaking. I went around. I used to talk a lot at WWDC. Ironically, most of my speaking gigs at WWDC were from before I was at Apple. Once I joined Apple, we weren't allowed to talk anymore. So, because you can't have enterprise people up there talking. So, did a lot of Macworld as well. When Macworld used to be a big thing and had the expo, I would do training at the expos. I would do speaking at the expos. Joel and I did several joint sessions at Macworld together over the years and had a lot of fun. The thing that most people knew me from back then was ASP548.com, which Joel and I ran together. The technical editing on books and things like that for Peach Pit and some of the other Apple training and such like that. So just a lot of all-around experience of being in the Mac with the Mac all the time. And this, predates Mac OS X, right, as being a widely deployed or even usable thing. So we did a lot of Mac OS 9, Mac OS 8. Remember the Mac OS 8, Mac OS 9 transition was really kind of funky and broken for a lot of people and things like that. It was a very different world back then. You used to go to the airport and you'd be the only person in the entire airport that had an Apple computer with your PowerBook. There'd be no other Apple products in the entire place except for you. And that's changed a lot now when you go to an airport, right? So along the time though, I kept trying to become a programmer. I thought this would be cool. I tried it first in college with my Quadra. I had a Quadra 660 AV, later a Power Mac G3, and I got Code Warrior, I got the Macintosh Toolkit, got all this stuff, and I tried in C++ and Pascal to program, and just was awful at it. I tried to get a major in computer science, and I failed out of school my first year, right? I had to take a semester off for academic suspension because I am terrible at math, right? So I failed out of school. That doesn't go over great with parents. Got to figure all this out, go back. So I have a degree in European history. I have a minor in video and film production, right? Because that's the stuff I like to do for fun. And so I always would tell people, as I'm in the bookstore, working there, being in the Apple store, doing FileMaker Pro database development and all this stuff for the sales to run on, that computers were that history is what I studied, but computers were what I did, right? So there's a lot of people in this room probably that are in that same sort of bucket, but I have no formal computer science training at all. I know some people that I can see in this room are actually lawyers that spend their time. I talked to a guy at the hackathon last night. It's actually a dentist, but he's here at Mac Sysadmins because he's really into this stuff. I tried again with Objective-C. And this book, which I really do not like that book. That is not a book that I enjoy. It is difficult to follow. And I've met a lot of people that have a lot of the same ideas. If you want a good Objective-C book, get the Tricycle book from Hillegas. It's orange, it's got a tricycle on the cover. Not only is that the best Objective-C book I've read, it's one of the best programming books on programming topics I've ever read. It is great. I did along the way, though, pick up AppleScript, first on the classic Mac and then on OS X. And then in AppleScript Studio, I made a little app called DNS Helper way back when that people use on OS X server to set up DHCP ranges in the DNS server because Apple didn't have one. I made it into John DeTroy's tips and tricks and thought that I had gone big time. I got into the cover CD for Mac User UK, and I thought, this is it. I'm on my way. I'm a developer now. And then Apple changed it all, and it never made sense again. I also picked up a lot of shell script, right? Which is probably the vast majority of what everyone in this room does. Who in here is comfortable doing a shell script? Probably the whole room, right? Yeah. It is a key fundamental building block when you're doing Unix-based systems and you're working on OS X or Linux or Windows now, right? Includes Bash and the whole Linux subsystem and everything else. So there is a lot of places that can take you. I kept doing all this stuff. I kept evangelizing. I kept working. I kept going after Apple and kept going after customers, and I kept speaking about it, writing about it, talking about it. Eventually, that makes Apple take a notice to you, and I got called to go to Apple. I got a recruiter phone call. I was like, great. This sounds good. Let's do it. And I was there for 11 years. I left in November, last November. The day officially at Apple was the day of the iPhone launch, the iPhone announcement. I sat in the audience. It was me and Joel and Eric Zelinka, and we sat there and we watched SJ do the whole thing. And then I got up and I left Moscone and I drove to campus and got my badge. And I thought, now I've made it. This is it, right? I'm finally here. I left the day the iPhone X shipped. So it's nicely bookended like that. I also left the week they opened Apple Park. So I've been to Apple Park, but only as a customer. I was on the Enterprise CE team, which Joel was on that team and then became the manager of that team. There's some other people around that have been on that team as well. Enterprise CE team, a lot of you guys are in education, so you know the education CEs with Dave Starr and those guys. The Enterprise team was under a bunch of different managers, but we did essentially the same stuff, but for Fortune 100 companies. At first, when I started, there wasn't iOS, so it was Mac deployment and management. I did a lot of this stuff, and I went around and I talked to Semantics and Altiris and all these people and did all this work on client management systems because there was no MDM, there was no iOS or anything like that. Apple finally started letting people in the enterprise group talk about phones because for a long time, remember, Apple didn't sell phones directly to customers. You had to go through the carriers, so all the carriers had people that did it. Eventually, we started talking about it too. And so then a lot of my workload switched over to iOS deployment and management, which was really hard before there was MDM, right? You had a configurator, or you had the iPhone configuration utility, right? Which had a Windows version and all this stuff and was strange. Did a lot of that stuff. From there, I started doing more app deployment and management. And I started messing around more with programming as well. Because mostly I have a coworker who said he would be in here, but he's not. And I saw the advantages it got with him. So I started talking more about app deployment and management and some app development work. And then finally, I put my head down again, decided one last time, I'm going to humiliate myself to myself with all this programming jazz. And it's not going to work out. But it did, because I've had a couple of key moments that I figured out of what I was doing wrong, or at least things that made it make sense to me. And it was like opening up an oyster, right? Yes, it was messy and gooey, and most people don't want to eat it, but it was pretty great also. App development and management, this being how I spent my last 4 or 5 years there, doing just in-house app dev on Mac and iOS, mostly iOS, and also helping big companies figure out how to engineer their development practices. Because it is not as simple as it sounds, and a lot of places don't want to put the resources towards making good apps for their employees to use. So we did a lot of talk about this stuff. The bottom line is I came in with sysadmin skills, and I left Apple with software engineering skills. And for a lot of people have said, well, that's because you were at Apple for all this time. Just being at Apple doesn't make you a developer, right? The majority of people at Apple that are developers are in hardware development, and they're all sequestered away in little buildings, and they don't get to see the light of day for months on end and things like that. So what I did to learn this stuff is I started simply with just being able to understand the code. Because Tim Perfit, who isn't in the room but is downstairs with his Two Canoes guys, with R2D2 and all that, amazing. Tim Perfit came onto the team to replace Joel. And Tim Perfit was a programmer already. And I saw the level of access and I saw the level of exchange that got him with the engineers that he interacts with as part of his job as a CE. And I said, I am jealous of that. I want that. So I gave it this one last try. And I came up with this idea of, well, I have to learn how to program a computer, right? So who in here has successfully written an app in something that's not Shell, not AppleScript? A couple of hands, right? One of the big things I tell people all the time that are coming from the sysadmin world and they're looking at development is that you already know a lot more than you think you do, which leads to this convenient acronym here. There's a lot to be said for the skills you already have. So one of the key things about this is I kind of went at it from a bit of a computer science way. And I had to figure out what programming was, how this worked. I took some COBOL classes once in college and failed them like disaster, like down in low teens for the grades. But I would get hung up a lot on that stuff because it's so low level, and it would be like, well, when you say I write a file, what does that actually mean? You know, I was getting hung up in the minutia of it. And so a slightly stilted example here is this example of programming. Got a text file, right? Everyone knows what that's going to do, right? It's going to print out that line. So all programming is, computer programming is you enter some text that's human readable text. A program, in this case a shell, the fish shell in my case, even though it's a bash hashbang script, will interpret the text that's in that file. It will then emit, although it doesn't really do this in this case, that's why I put a generic terminal icon up there because I'm wiggling a bit. It interprets that text and it generates actions that are going to happen. That code executes and it prints hello world. Right? And I know this is now what a lot of people are thinking about this, is you're like, I already know that. That's scripting, that's not programming, you know, what is going on? But it is programming. Don't let anyone ever tell you that scripting is not programming, because it is. It is a way that you are going to work through your code to have a computer do something. And to drive this point home, let's replicate that program in Swift. I take a text file. I enter some text, which looks shockingly similar to that shell script text, right? The difference is instead of just running it in the shell and having the shell interpret it, is I run it through a compiler first. That's the Swift compiler, Swift C. It compiles that. What it does is it reads that source code, and it then emits a binary. It says, okay, here's just the machine instructions that needs to work. And then when you run it, it prints hello world, right? Now this led to an epiphany, also known as a tower experience if you're either a European history major or a Lutheran. This will make sense to you. This is just this is a moment where you had an understanding that came to you from just out of the blue. Your eureka moment. And I realized, as I worked through these books and everything else, that I was good at shell scripting already. But that programming in Xcode, all I'm doing is scripting in Xcode. I'm scripting the APIs in Xcode, right? That's the important part of this that I found. Because when I made this mental adjustment to realize that the API, what a command line tool you call in the shell, the equivalent of that is an API you call from code. They do the same things. It's the same syntax a lot of times. Even in Objective-C, it's the same syntax a lot of times. So if I just treated the system APIs like they were command line tools, file manager, right? And I just knew what commands I could give file manager, then my programs work. This opened up everything for me personally. It may not do the same for you. But this is the knowledge that I finally came to, the realization that I didn't have to get buried in hex and pointers and dereferencing things. All that's just noise, right? Especially now with modern languages like Swift, where Swift doesn't surface all of that for 99% of what you want to do. So it got to the point there where I was able to take that and then I could convert things. So here's some quick examples. Shell and Swift. Printf I already showed you, right? Printf is print. Those make sense. How about more things? If I want to work with strings, right? I want to load strings and work with them, rearrange them, things like that, process them. Well, I mean the file system. Sorry, I skipped that one. If I want to look at the file system, copy files, move files, delete files, move directories, everything else, I can use this collection of command line tools that everybody knows. Or I can use, there's an API called, conveniently enough, File Manager. And if I just look at the File Manager instructions, I can see, well, if I want to move a file, it would be MV, this, where it is and where it's going. In File Manager, there's a pretty roughly equivalent sort of action you can take. So at that point, you can just sit there and go, okay, well, I want to move things. How does File Manager say to do that? And then you can read it. And then when you write your code, if it's in the shell, you would say MV something, something, something. In your compiled code, you would say File Manager something, something, something. And it works the same way. For the string, we have awk and grep and sed. How many people love regular expressions, right? Figuring out sed, and it's like sed, forward, backward, slash, slash, you're flapping your wings like a chicken and all this stuff. There is a type there are several types actually on the Mac and on iOS, just called string, that almost anything that these tools can all do together, that class can do by itself. You just get a string loaded in. You can say, hey, string, fill yourself with the contents of this file on the disk, and it will become a string filled with the contents of that file from the disk. You can say, hey, string, save your contents to a file on the disk, and it will just write them out for you. You don't have to do anything else. You don't have to do fopen. You don't have to get a file handle. You don't have to do any of that stuff. You just say string, write, and it will write it to disk, wherever you say that you have permission. If you want to go through it, you can treat strings in Swift. They are actually arrays of characters. So you can say, give me a random letter from this string. It will give you a random letter. You can say, reverse this string, and it'll just reverse it. You can say, uppercase it, lowercase it. You can get crazier. You can use the semantic mapping stuff. You can say, tell me what all the proper nouns are in this string. You can say, give me all the adverbs that are in this. And it just does it, right? I wrote a little app at Apple to demonstrate this once that I called Monkifier or something like that. But inside Apple, there was this famous story about how someone filed a radar once and said, OS 10 doesn't have enough monkeys in it. I thought there'd be more by now, right? So it's like, okay. So I made this little app that would take a block of text and it would take all the nouns out of it and replace them with the word monkey. And then I submitted it, I attached it to the radar. I said, maybe we can close this now because I've written this little app here. This will add monkeys everywhere in the OS. It'll be great. If you're going to use curl to download something, you can use URL session. You could, if you want to be all C-based about it, use libcurl and use curl, but use it from the API side, which is what curl uses when it curl runs. plist buddy, lots of people know plist buddy, right? You can use a dictionary. You can tell Swift or Objective-C on the Mac, hey, dictionary, fill yourself with the contents of the file at this location. It doesn't care if it's binary. It doesn't care if it is string. It doesn't care if it is a JSON plist, which you don't see a lot of. They have dropped support for the next step format plist, the plist 1.0. Those were only supported, I think, on Rhapsody server. They've not been supported on any version of OS 10. And then you do this in dictionary, and you get a dictionary that you can just manipulate and edit and change and read. You can, with dictionary, with NS Dictionary, you can say, hey, NS Dictionary, go to this URL and fill yourself with the plist that's at that URL. You ever wonder why all the Apple configuration URLs lead to these plist files on the internet, like the Misu and the software update ones and all that? That's because they use dictionary. They just say, all right, get the contents from this URL, and it will just go out to that URL, fetch the contents of that URL, bring it back, and give you a nicely formatted dictionary right there. If the world had adopted that rather than JSON for a lot of stuff, things would be a lot easier placed because the plist format is very rigid and very strict. Half of what you do with JSON parsing is figuring out what the things in the blob of JSON are, right? Whereas with plist, as you guys know, plists are very strict from start to finish. Again, we've got defaults. If you use the defaults command on the command line, you can use the user defaults API. Same sort of thing. You can say, hey, get me the default settings for this setting in this place, for this app. If you wanted to spawn a shell process, you can do that in Swift and Objective-C too. You can just use the process task in Swift. And this will let you spawn out a Unix task. So if you find something that you need to call grep from the inside of your program, you can use process and get this nice objectively wrapped sort of process with input and output and everything else. So you can write wrappers around command line tools. The main thing I want you to look at from all of this and take away from this sort of stuff is that you can do this. If you can write a shell script, you can write a Python program. If you can write a Python program, you can write a Swift program. The main difference, once you get your head wrapped around what you're doing, is syntax. And I know that's a bit like saying the only difference between a book in French and a book in English is the words on the page, right? But it's kind of true. It's easier with programming than that because the basic tasks we're doing are generally the same in every language. I want to copy a file. What's the syntax in this language? What's the syntax in that language? So as far as becoming a programmer, that's step one, right? There's this other step then that I took with my work with all of these big companies, and that is taking a look into software engineering and figuring out what that was and what that wanted to be. Do you want to be a programmer? Right? That's one thing you can do in software engineering. Do you want to be a scientist? Who is that? Someone in here knows who that is. Yes, that is Rear Admiral Grace Hopper. There are YouTube videos of her teaching computer science courses at the Naval Academy that are on YouTube. They are incredible to watch. She has one where she talks about how much a nanosecond is, or a microsecond. I'm talking about computing time. And she had the engineering team make her a piece of wire that was the length of a microsecond of light or electricity traveling through a wire. And she's like, this is the length of a microsecond. And she had a piece of wire. A similar thing I've read about that I saw Mike Ash talk about once was that in a computer, if the memory is more than 4 inches away from the processor, you can't physically fetch memory in less than 1 cycle. It's too far for the electricity to go at the speed the processor moves. So that's why a lot of things like they talk about Apple does all their own custom chip layout, and Apple's ARM chips are really fast and efficient. That's what they're doing. Or do you want to be an engineer, right? So there's a whole bunch of different things that you can do here. And what are the differences between these disciplines in the very loose, mushy world of computer science? Well, first of all, the Wikipedia says a programmer is a programmer, a developer, a dev, a coder, someone who makes software. Who knows who that is?
John Carmack.
That's John Carmack. He is one of the most brilliant programmers of the 20th century. I mean, he is, one of the things I found about him described him as a young child as a brain with legs. He has a rocket company. He made Doom and Quake and all that stuff. And when I say he made Doom and Quake and all that, he wrote the vast majority of that stuff on his own. He developed all the rendering technology. He did all of that in his head. He currently runs all the tech stuff at Oculus. So it's pretty amazing. Remember when the App Store was brand new? We're at the 10-year anniversary of the App Store, right? The App Store was brand new, and then Doom appeared on the iPhone from id. That was his weekend project. he ported Doom to the iPhone just to see if he could, and he did it over a weekend based on his original source code that he still had on a Nextcube that he dug out of his closet somewhere. He maintains a .plan file still, which nobody's done for 100 years, but it's full of all sorts of stuff like this where he documents all that. It's basically a blog. Computer programmers, originally, this was a data entry job, right? Computer scientists worked on the machines. That's ENIAC. That's Betty Jennings and Fran Bilas. Doubt anyone knew who those were. They were two of the original 6 women that programmed ENIAC. Because the men would be, oh, here we go, let's do this stuff. We designed this computer. All right, now here's the program. You data clerks go enter in the wires to make that work. But what really went on was that it wasn't just that. They were the ones that, while the computer hardware engineer would decide what algorithm he wanted, these women figured out how the algorithms would have to work. And as a result, most of the early computer programmers were women in the United States. They write software in a computer programming job. Generally, computer programming now is called software developer. No one really says I'm a computer programmer anymore. It's kind of an old school sort of thing. There's another slice of computer life, and that is computer science. And a computer scientist, who knows who that is? That is John von Neumann. He may be, and he is Einstein-level brilliance. He made a computing architecture in the 1950s at Princeton. And you know how many computers use that architecture today? All of them. There were Princeton architecture and Harvard modified, right? Harvard modified is actually what's inside a lot of CPUs today. But he designed how all computers work. He also designed atomic bombs and all kinds of other things. He is a terrifyingly smart person. But what does a computer scientist do, right? They think about computing. People that have PhDs in computer stuff, those are computer scientists. You know who that is? Ada Lovelace, that's right. The first computer programmer. She worked with Charles Babbage. Something a lot of people don't know about Charles Babbage is he never actually finished the analytic engine, right? Charles Babbage was very much the dog at the end of Up with the squirrels and never actually finished most of the projects he's famous for. The analytical engine was actually never finished in his lifetime. Someone has recently built one because internet, I guess. But, you know, she actually wrote the first algorithms designed to be executed by a machine. So computer scientists, they design hardware, they study algorithms. They like to write things in big O notation, right? Where you look and you see it'll say, oh, well, that is O3 algorithm. You know, and you're like, what? You know, they're like, well, that's kind of cyclomatic complexity. And you're like, what? So it's very fascinating. They worry a lot about if P equals, oh, I hit the wrong button. Or did just the, there it is, okay. They write a lot about P versus NP. They worry a lot about this. See, there's Tim. Tim knows about P versus NP. Are they equal, Tim? Now that you're 40 minutes late? I talked about you earlier. So they worry about all this sort of stuff. That's what computer scientists do. Computer scientists are very much in a theoretical realm. Although some of them work, Chris Latner is another example of a computer scientist. One of the things they do is they design languages, they design hardware, they figure out the really hard, big stuff. All the people working on quantum computing right now, those are all computer scientists. Those aren't just developers. We also have software engineers. Software engineers, anyone know who that is? These are all tests. There's Edgar Dijkstra. He's the guy who wrote "Go-to is considered harmful," right? He hated the term software engineering, but he is pretty much one of the founders of software engineering. He is the guy who invented structured programming. Before he came up with structured programming, everything was based on line numbers. You'd have line number 1, line number 2. Then you'd say, go to line 6, go to line 9, go back to line 1. There's a lot of mistakes in that. Apple had one a couple of years ago, go to fail, remember, with SSL? He was right. And software engineering is taking the task of computer programming, of computer science, of all these sorts of things, and applying engineering to it so that we get reliable code. And it's more the art of making apps sometimes than the actual work of coding apps. So software engineers, they formalize the practice of software development, and it's focused on quality and how. Who knows who that is? Yes, that is Margaret Hamilton. Margaret Hamilton worked at MIT. She is standing next to the guidance program for the Apollo 11 mission, right? She wrote the software and led the team that Apollo 11 ran on. She is the person who suggested the term software engineering to be used to describe what people do, as it will bring respectability to the profession of computers, which in the 1960s, 70s, even 80s, a lot of people thought were like, that's not real science. Those are toys and stuff. I mean, how many of you had your mom tell you, quit working with that computer all the time? And now they're like, could you come please fix my computer? No. So she came up with that term. There's a famous part of the Apollo landing when it's coming down, and there's a computer buffer overflow. And you hear this voice in the background go, okay, good, good. That's her. We're done with the history exam now. So software engineering is about the how of how things work. So I did, in my time at Apple, I used to go around and I would look at the existing software engineering practices of internal teams at major companies, right? And it was not pretty a lot of the time. So I have a couple of examples that are very anonymized. If any of you recognize them, please keep it to yourself. I hope none of you will. But last year I went to a customer. When I worked for Apple, I went to a customer that had a Mac app. And they had to build it on Leopard. They had to maintain Leopard VMs and Leopard machines so they could actually make the software that ran their business, because they didn't want to put the resources into upgrading it. Because it works, why would we change anything? Well, there's a lot of problems with this approach, right? There's technical debt, and then there's technical debt, right? So this is a bad place to be. I've been to customers that recreate all of Apple's APIs with their own code because they want to make sure it's good, right? But then they have to maintain their own parallel version of UIKit or something like that. Lots of times at these customers, lots of times on Stack Overflow, lots of times on GitHub or other places I go to look at things, people say, well, I use XYZ framework because the Apple stuff that can't do that. And then you go, oh, well, yeah, that's supported in the Apple frameworks. And they go, since when? And you're like, 2012? I don't know. Have you checked lately? Read the documentation, right? So this is a big waste of time and money for a lot of things. You can spend forever and ever. If you're doing something unique, that's great. If you're doing something that you really need to differentiate yourself, which there's plenty of that people have to do, then making your own APIs is great. But spending tremendous amounts of money and time recreating what's already there is not necessarily the best use of computer software engineering time. I once went to a company 2 years ago, sat in a room with several VPs, the CIO, and a team of 8 developers that when asked, hey, can we see a look, can you show us the production source code in your source repository? 8 people couldn't find it. This is a major multinational corporation. So, and it's not Apple, although a lot of times you might think that. So, this was one of the most excruciating, I'm feeling embarrassed for these people moment that I've ever had. Because they're all sitting there huddled, and you could see the CIO looking at his watch, checking his email, looking back. This took 10 minutes of them in silence, pouring through repos. It's also that same day they told me that there was no leaks in their code. We have no leaks, no memory leaks. Well, the crash log you said seemed to indicate there was a leak. You're still using Arc on iOS, which That was they're not using Arc. They were still doing manual memory management on iOS, which Apple got rid of on iOS a long time ago. And so I said, you probably have leaks. And they said, no, we have no leaks. Well, how do you know? Well, we know. We coded it right. I was like, well, let's see instruments. And it leaked so much memory, hundreds and hundreds of leaks a minute, that the app would only run for a little bit of time before the iOS device would just kill the app. So you're out of time, you're out of memory, which was the symptom we were there to fix, right? So it's like, well, there's the problem. And they're like, well, how do we fix it? Use any programming technique from the last 10 years, right? There's no magic bullet for any of this. You have to sit down and do the work. I talked to a major company once. All the code, they didn't have a repo. Everything was on the main developer's laptop. The whole code base that ran their business. That's insane, right? Because this happens. When I worked at Computer Tree, we had someone come in once on April 13th or something like that. What's tax day? 15th. So someone came in on the 13th, the beginning of the week. Their computer had died. The hard drive died. And although they were not a professional, they did do tax preparation for all their friends and family. And they only had one computer. And everything was on the disk that had just died. Take a backup, at least. You know, if you're going to do tax preparation for people, you might as well have a way to get back. There's only a couple more of these. A build system. This goes right to the core of software engineering. A build system that not only is brittle, but is also slow. We had a company that had a build system that built all their customers' products, versions of the same product, one at a time, in alphabetical order. It would start at the top, it would work its way down the list, and one day, something happened and the app quit working, and they needed a new build. And there was one customer of theirs, of this multi-international company, another multinational company that was a customer of theirs, said, we have to have a copy of this, otherwise we are not going to be able to operate hundreds of millions of dollars of stuff in like just a little bit of time. Oh, my workout's still going. Send that. That'd be pretty good. And that company started with a U. And they started at A. They couldn't just say, build for the U guys, build for the X guys. You had to start at the top and work your way down. They had no way to just do one or the other. That is incredible. And it was like this nail-biting, oh my God, what's going to happen sort of moment. I saw this in one of the rooms yesterday, too. I've seen an iOS app that has almost 20,000 classes in it. 20,000 to make an app that runs on your phone, right? And when I ask what they do, they don't know what a lot of them do, but they're afraid if they take them out, it'll stop working. So they just keep adding. That's a large amount of technical debt. I'm not going to tell, and if you guys come and ask, I will not tell you who any of the people in this work. They are all companies that you know. They're companies that your parents know, that your kids know. They are all companies that it would shock you if you knew the stuff that went on.
Are you flying on any of their planes?
That wasn't any of them, but going into that stuff. So this was where I came from, and then I had to work with Joel on code. So there were a lot of problems at Orchard and Grove that I had been kind of watching Joel from afar as he was doing stuff, right? I've known Joel for 20 some odd years. We've been collaborators from the beginning of ASP548.com, time at Apple, time outside of Apple, everything. We've worked together on tons and tons of things. And one of the problems is that he kind of he likes to just go with the flow, right? This is great if you're selling stuff. It's great if you're friends. It's great if you're hanging out. It's not great when you've got Git repo commit access and it looks like Guitar Hero, right? So when I got there, there was just source control madness. Okay, who in here uses Git for projects? Right? All right, what do you call the main branch that is the one you publish your code out of? Master. No, he calls them experimental. Master is a branch, but that's not the one that the code's in. It's like, look, there are just some things. So there was a lot of source control madness. A lot of waterfall management going on for stuff. I'll talk a little bit about the difference between waterfall and agile here, even though we're not completely agile with a trademark symbol next to it. But we use a lot of that. There is a lot of copy and pasting of code going on, which those of you that use Git, take a file, open it, copy all the code out, delete it, paste it back in, run a diff. What happens? The whole thing is just like, all these lines have changed because they have. Even if you put the same stuff back, it's not the same bits. So we had a lot of that. A lot of duplication of code that I had to figure out and work my way through. A lot of naming that is confusing. These are all actual repo names that we've got. Well, I want the one that does authorization. Oh. Maybe versioning, and I actually wrote a blog post on our webpage about the versioning transition we're going through. But we have lots of weird versions. Versions are just kind of were whatever, before I got there, we're just kind of whatever Joel thought would be a good number for this one. He liked to put the build number on the end of it as the patch number. And all that. I'm like, look, there actually is a standard that's a recognized standard for these things. We can do that, and it'll make things easier. So how we did some of this, right? How we do it now, no more waterfalls, right? We want to go ahead and we are more agile now. We aren't completely agile. There's not enough of us to do that. Agile is one of these lightweight programming and project management architectures from the 2000s. There's also extreme programming that has an X in it and things like that that makes you do pairs programming where two people share a keyboard at every computer, and there's all kinds of crazy stuff, right? But what it just means is we break the work up into pieces of work that you can get done in a certain amount of time. And then we file those under milestones, right? So, and then we say, well, these 10 things we can do in the next month. Let's break them into work-sized chunks, put them in there, we'll set a deadline on it. And then by the time we get to the deadline, either they're all in there or they're all not. One of the great things that Agile does is, how many people have ever worked on a project where you start working and there's this big waterfall Gantt graph and all this stuff, and you start here and it doesn't actually work until you get to the last one, right? You have to get all the way down for all the pieces to be together. What Agile does is at any day, any particular time, you could just quit and say, that's enough, it's not everything we wanted, but it's good enough, and the product would work. You work on it as a feature by feature basis. So we always come up that the master always builds. Master will always build and make the shipping product, no matter what. This was new to some of my colleagues. But so were warnings as errors and things like that. I'm losing my microphone. There we go. So master and feature branches always build. Source control. Oh, right? Source control can be difficult to explain to computer scientists, right? Here's a fun project for you. Read a couple of the man page. Read the man page for Git, just a little bit of it. Then go online and look up the Git man page generator, which generates pages from gibberish. You cannot tell, if not prefaced, which one is which. I mean, it's eerie. So we went for a modified Git flow. My Git flow is simple. You make an issue, you make a branch, you merge it back together. It makes it easy to track things, and then with the automation that we get from these wonderful tools you get for free on the internet these days, it makes it easy to work through it. So if we make an issue, hey, you make it a feature request or a bug report, whatever we want. I got this cool thing I think it should do. What do you want to do? Why do you want to do it? Those are the little bits of work that we then break down if they need to be, and we sort them into milestones. There's a milestone. That's the milestone that I'm working on for login window, Nomad login AD, 1.2, Cruel Cabbage. We're getting there. There's 8 merge requests out on it right now, so I need to get in and do code review and all that stuff, but it's there. Branching, we make a branch for master, which you can see is default branch. It's protected, so you can't merge changes into it without going through code review. So there isn't just willy-nilly, oh yeah, I updated the build, and oh, what? So it's protected. When we decide to make a milestone, you can see the one above that is a milestone branch. That's the one we work on the features out of. Above that's a feature branch. Now that seems like it's a lot to do, but it's not, because there's automation that takes care of all the details for you. on GitLab, on GitHub, on any of these systems. It'll do all the work. You just click the buttons. Merging, merge it into the milestone. When you're done with the feature, you merge it in, you delete that feature branch so it's gone, right? Because why are you going to keep that old stale branch around? You've finished that work and it's been pushed in. Here you can see, this is some GitLab here where it's gone through. It said there's a request to merge this. It's run some continuous integration and build tests on it. Yeah, this code builds. It'll all be good when you're ready to go. It's not going to have problems. Now, that would be a lot of work. And when I was at Apple, we were on GitHub Enterprise for a while, and it was a lot of work. We had to do all this stuff locally. You can do most of it in Xcode. Some of it you had to do with Git command line. Some people had Tower. It was lots and lots and lots of stuff. But if you use something like GitLab, and even GitHub has these features now as well, it does all of it for you. So here I've made an issue, and then I can click Create Merge Request, and it will build both a branch and a merge request automatically, right? Just by clicking the button. There, that's done. I don't have to do anything about it. It automatically then relates that issue to the merge request, so it connects the two things automatically. So now when I look at my issues, I'll see, oh, there's a related merge to that. And I click the button, it'll go right over there. Oh, I've got to wait for the screw. There we go. All right, I think we're good now. There's a continuous integration pipeline that runs. I've got a Mac Mini at my house that just has a GitLab runner on it in Xcode. And so every time we do a merge request, it'll automatically download that code, build it, make sure it all builds, post the resulting product back to GitLab attached to this. So you can actually go in here and you can get the state of the product off any one of these steps and see the build history for it and things like that. It's ensuring the quality again, right? That's one of the things in, wait for the screen to come back. That's one of the things in software engineering, the idea of quality, is that we want to make sure that everything is there and running. And they're working on the screen. So it just is a way to get that out there. I'm working towards getting full unit testing and everything else in our code. There was none of that when I got there, and it's hard to add it in later, but we're adding it in as we fix bugs. You make it if you fix a bug, you also have to write a test to verify the bug is fixed, and then that gets added in. And then here's the real magic part of using these automation tools. At the end, I say merge it. That merges it tests that the projects can be merged. It will execute another build test. It'll say when these are done, when the build test succeeds, I will merge these. It also then automatically deletes the source branch. It automatically closes the issue with a comment that this was solved and landed in this merge request over here. All I do is click one button, and all that happens automatically. And then I'm able to look back, and we can see exactly, oh, that line of code, what were we doing with that? And you can always look in the blame and see in the blame where things were, but it's easy too now. You can look in the blame, and then when you follow that line through to here, you can see what build, what feature, what it was related to, and it's all put together automatically. Versioning. And you saw all those version numbers earlier. We had someone today, we asked what version of Nomad you're using. It was like 1.1.3.8886. It's like, oh, okay. Well, we only release finished ones, so I don't know what the 8886 is on there for, right? we don't have that many public revisions of it. Semantic versioning is what we're using. It's a widely adopted standard. If you use CocoaPods, if you use Carthage for package management, if you use Swift Package Manager, all kinds of stuff, it is all based on this kind of versioning. And it's very simple, right? The first number is the big release, the second one's the feature, the third one's a patch. And the way this breaks down according to the spec is if you release an update to the app that doesn't make any changes for the users at all. The consumers of your app won't even notice it except maybe bugs are fixed or it's fast or whatever. That's a patch. If you add or change a feature, but you do it in a way that's backwards compatible with what they already knew about, that's the middle digit. That's the feature one, right? I've changed something. I've added stuff. Nothing broke, but there are new things you can do. The one all the way in the end is for major releases. I've updated this, and something is different now in the way it's going to have to work. trying to get my microphone back. And the way it's going to have to work, that's when you go out to the big one. It means your version numbers don't go racing up as fast as when you go, well, this will be version 2. This one is version 3.1. You know, it's a much more pragmatic way to do it. But if you're using package managers or other things like that on the internet, for most languages, they all use the same versioning system. So if it works for everybody else, it works pretty well for you as well. The naming, this is one of the big things I really got angry about when I first got there. You want Nomad? You want Nomad? I got some other Nomad over here. We've got this Nomad product. We don't want to be the typical enterprise vendor, right? We want to be the enterprise vendor that you go to the web page and it's clear and easy to understand which product does what and how much it costs and where you can get it, right? If you go to these enterprise-y pages, it's all just, please give us your email address and we'll call you and then we'll talk about it. They don't want to let you know. Go to Semantics webpage and try to find information about a particular product. And it's maddening. How much does it cost? What platform does it run on? I don't know. If you have a customer you go to and you need to look up support documents for a product they own, you can't because you're not the customer and you have to pay to get to those. We want everything to be easy to do. And so what we're doing, and we've started doing with the names, and we're doing this as we release, is we're naming things based on what they do, which I know is a groundbreaking idea, but we have sensible names. Nomad was already named, no more AD. We kept that name the same. But when the first new product that I oversaw came out, Nomad Login, that worked with Active Directory, we got crazy and we called it Nomad Login AD, right? So things make sense. When we have the next version of Nomad Login that we released, it's Nomad Login, but it does Okta, so it's Nomad Login plus Okta. When we add Azure, it'll be plus Azure. When we add Ping, it'll be plus Ping. It'll be, oh, that's the product I want, and I need the version that does that directory service. There it is. I don't know why a lot of enterprise folks try to make that so hard. I know, right? There's been some crazy version numbers all the time, naming on stuff. But overall, we're trying to get this down. The big one I'm working on right now is changing Nomad Pro, because people always think, well, I want the Pro. It's like when you buy paint thinner, right? You don't go to the hardware store and go, professional strength. Well, that's not for me. I'm an amateur at this paint stripping stuff. Put it down and get a different one. People see Nomad Pro and they're like, well, that's the version we want. And well, do you have Okta? And well, no. Okay, well, then that's not the version for you. So I'm working on getting the name of that changed to Nomad plus Okta. The non-AD ones are open source and free. The non-AD ones are the plus products and they are per seat licensed. The other ones are open source and free. Cloning, right? All of this duplication that we had, right? This is actually a picture on my computer of some of our checked out repos, right? Which one's which? Well, there's Nomad Pro, but there's a workspace for Pro outside. There's PKI7, there's PKINet, there's private, there's AD, there's AD auth, there's, what do all these things do? And while the naming was for the consumer side, this is for the software engineering side. So what we're doing is we break the projects into chunks. The first example of this was the AD authorization framework. So now when we need Active Directory in a project, we can bring this framework in and we get all of our AD stuff is in one thing that comes in. It's not the same source code copy and pasted 3 times into 3 different versions of files that are almost but never quite the same, right? Because you can't keep up with them. We have another one that does Okta. We have another one that handles the product licensing on our products that are licensed. And these are just frameworks, so we can just bring them in and put them in there. Now, there are some challenges with this, right? Dependency management is a problem. How do you make sure you have the right version of the framework somewhere? And Swift has this wonderfully named, tantalizingly named Swift Package Manager, right? That's part of the Apple Swift language, developed in the clear. Doesn't do dependency management for Xcode, though, which you're like, what? It's for Swift and only Swift, and the only app you can build from the Apple ecosystem and Xcode with it that's supported is a command line Mac app. You can't build iOS with it. You can't do other stuff. For Swift, pure Swift projects, it's really great and it's fun, but for doing multiple Xcode macOS Cocoa apps, it doesn't really work. So right now we're using Carthage for our package management. Carthage is preferred over CocoaPods. CocoaPods is the only thing I've ever seen called out in an Apple Xcode release note as if you use CocoaPods, that may be why you've had problems with Xcode, not because of Xcode. It's the only third-party product I've ever seen called out in a release note from Apple. So, because they modify the project file mechanically, and it's an undocumented format. The other issue, if you came to the Swift stuff last night, you heard a bit about Swift, the ABI and module formats. Right now with Swift, you can't just make a framework and then put it on a file server and drag it in when you need it. You have to build the code with the same version of the compiler that the rest of the code builds with. Carthage does this automatically. With Objective-C frameworks, you can just put them on a file server, and when you need to use one, you can just drag copy it into Xcode and it works. That's because of the ABI stuff. This is getting fixed very soon as well from Apple. The results of all this is we've already started to have better names on our products for our customers. Also for our customers and also for us, it makes it faster for us to iterate through products. The fact that just the two of us can maintain now, we've got 6 active projects going that are major pieces of software. Everything from smart card, PKI and NIT smart card login software to Okta software to Active Directory software. There's just 2 of us doing the development, really. So we can keep up with that. Less duplicated work. One of us isn't working on a file only to find out someone else is, the other guy's working on the same version of the same file somewhere else. So more products with less effort is really the goal. So in summary here, development requires love, right, to be a software developer. Steve Heyman is doing the Everyone Can Code talk this week here as well. Steve is one of the first to tell you everyone can, but not everyone should, right? If you really love sitting there in front of a computer and staring at code and working it out and debugging it, because the other revelation I've had over the years is that all programming is debugging, right? It is. Your initial program is a blank screen with no lines of code in it. That program does not work. You have to add lines of code and fix it to make that work. That's all you're ever doing. If you can write a script, you can write compiled languages. You just have to learn the syntax. Think of those APIs as the command line tools you would normally call in the shell, right? But if you're going to be a software developer full time, you might really need to love sitting there solving bugs. Because like I said, that's what it is. It's a lot of staring at a screen and going, and looking things up and working on things. Everyone thinks it's going to be like, I'm typing away and apps are going to come flying out. It's not necessarily like that. Software engineering is a practice that is about the how of all this, right? It includes writing apps. It includes designing build systems. It includes all these things. And that sounds really familiar because DevOps is part of computer science. A lot of people in this room would be what is today considered DevOps folks, right? You make a monkey server and you then manage that server and that server builds endpoints and all this. That is classic software engineering because you're taking all these pieces, you're designing reliable systems to build out products, to build out the needs of your company, the needs of your school, the needs you have at home. So when folks talk about software engineering, they talk about computer science and everything else, it's not as confusing as it has to be. A lot of you probably may, with that, come to the realization that you already are doing software engineering. It's just that not all software engineering is the same. So I love talking about programming with people. So we've got time for some questions here. And any of this stuff that you were interested in, we'll be doing more hackathon stuff tonight. Tonight's the Go night at the hackathon. We have a different drink tonight. And tomorrow night will be Python at the hackathon with the bottle share outside. So again, 8:30 is when the hackathon starts tonight. And it's a different language, although we can all work on the same languages if you want to continue what you did last night. We had a packed room. We had people on the floor sitting and working on Swift last night because we didn't have enough chairs. So, and we were there till 12. So it was a lot of fun, and you can come and join in on that. So any questions based on this stuff? And I've got the cube thing, which I'm supposed to throw, but that feels weird. So if you want to hand that there, and you can toss it to him maybe. It's just there's computers and water everywhere.
For the Go Hackathon tonight, it's on?
I have no idea.
Testing.
There you go.
For the Go hackathon tonight, is there anything that we need to prepare? Like last night we did Xcode.
Not that I know of. I would ask in the PSU hackathon channel just to double check, but we've not heard of anything that's required up front. Because I think they're going to, I'm not exactly sure which tools they'll be using, but that's a good question for that channel,
Sure.
just to make sure. That way you aren't blindsided on the Wi-Fi and everyone trying to get it at once. So, more questions? I saw more.
Yeah.
Oh, are you going to throw
Pass
it?
this down, please.
You can, I mean, you guys can throw it if you want. I'm just not going to do it.
Thanks. All right, can anyone hear me?
Yeah.
So I got a couple of questions there.
Sure.
One of them, I'm kind of in a similar same boat as you. I had a non-CS degree undergrad there, but I always wanted to kind of break into the software engineering field down the road. In addition to obviously learning like program and certain scripting and stuff, is there anything else we should also be like kind of be looking into if we wanted to like break into software engineering, like any type of soft skills or like?
Yeah, soft skills, different kinds of management styles, right? Like in different product methodologies, like the Agile or the Scrum or whatever. What I actually did, because all of it was gobbledygook to me, I went and I bought the Agile Development for Dummies book, the actual yellow and black dummies book, which broke it all down in a very nice way. And you don't have to read the whole book, and you don't have to memorize every page, but just having an understanding of how those sorts of engineering teams work goes a long way, because when you come into something that's that way you at least have an understanding of the way it's going to work. I found that did a lot towards having a good understanding of the way that stuff is done, the way things are built. And so when people talk about sprints and stand-ups and scrums and all that, it makes sense to you, right? So I would look at some of that stuff.
Now, you also mentioned something about like the math component being like one of like the biggest factors behind like CS curriculum there, and I'm also in kind of the same boat. The math part kind of killed me back then.
Oh, yeah.
Could that possibly like come into play down the road, like if you absolutely need it, but like something may come up with it?
So what I've found about the math is that when a math concept has come up, it hasn't been, because it's not a semester of me pounding my head on the desk. It is a specific algorithm or solution that solves a problem that I'm actively working on. I can do that. That I can actually sit down and get enough of a grasp over it. Programming today, there isn't much of that. You really aren't doing, I mean, you're not doing bit shifts, and you're not doing complement subtraction and all that stuff. You're just using frameworks and code. I find it very fascinating. I read a lot of computer science stuff on Wikipedia. I read a lot of computer science books. There's a great book called Code from Microsoft Press that is fantastic for how computers work, how relays work, how electrical engineering works, the basics of encoding and coding languages. He walks you all the way through building a computer and an operating system in terms that I was able to read at the beach and fully understand. So.
And I got one last question, I promise.
Sure.
So in this day and age, it seems like human resources are more like structured for wanting to like seek out people that have like experience or like the actual degree in like software engineering or computer science. What are some best ways one can kind of go about putting themselves out there inside the job market, so to speak, like portfolios or like something to kind of show that like I don't have a CS degree, but I'm like trying to work on like becoming a software engineering major. Please look at me.
Yeah, open source is really good for that. A lot of times, if you are active in even forums for open source communities without writing actual code, right? If you lurk in the swift.org forums for a while, and then you're able to answer questions, even if you're not actively writing apps, you still become a voice of knowledge in that community. Contributing code to projects, posting projects, as you learn things, posting it publicly to GitHub on your own, even if they're ugly, posting stuff up and letting people look at what you did, and you'll start to get followers on GitHub for reasons that you cannot fathom, and you're like, why is anyone following me on GitHub, right? But it happens. It's just someone sees your code comes up in a Google search or a Bing search or a Wolfram Alpha thing, and they start looking at it and go, oh, that's cool, and you get a star and you get a follower. And it's very kind of organic sort of stuff like that that works a lot. Having a portfolio, having skills is more important than having degrees when it comes to like development work. I've not found anybody yet that says education is a hard stop. I've even, even at Apple where they really prefer it, every time I've seen hiring managers and engineering managers on Twitter or other places where they say, hey, we're looking for this person must have advanced degree in computer science. And someone says, well, I can do all this, but I did it myself. I don't have an advanced degree. And they're like, well, the education thing is just to weed people out. We want to make sure it's not someone who's read machine learning for dummies, applying for a job, and you're writing algorithms. They want to make sure that you actually can do it. So I've found overall that education doesn't matter nearly as much as experience as far as that goes, which I think for IT in general is pretty much an overarching thing. I mean, you hear at a computer conference and you're not with a computer degree as it starts. Joel's a journalist. I'm a historian. I mean, it's just kind of how it goes. So I would focus on learning some key things that seem popular in the field you want to do.
All right.
And then looking for ways to participate in those communities, because that'll get you noticed.
Gotcha.
Anything else? Oh, there you go. One more back.
Can you pass this over? Thank you.
I know you had mentioned one book there, and I didn't get the name exactly.
The code book, or the book at the beginning that I didn't like.
No, the good one, the good book
Yeah.
that you liked. Are there any other books that you recommend, or iBooks, or eBooks, or whatever?
Yeah, and you know what I'll do? I'll put a list together and I'll post it in the PSU Mac Slack. How about that? Just off the top of my head, there's one called The Code Book, which is just about the history of encoding things. It starts with Mary Queen of Scots and her failed cipher that ended up getting her beheaded, and goes all the way through to quantum computing. There's actually a TV show version of it that's on Amazon Prime too, which is actually really good. That book, there's a couple of other programming books that I really like. Apple has a lot of curriculum just for the straight programming stuff. If you want to learn Swift, we talked about this at the Swift hackathon last night some. Apple has both middle school and high school curriculum with teacher guides and student guides that you can work through on your own. So there's a lot of, more than ever, there are great resources for free out there to learn this stuff now. It isn't, back when I was a kid, I had to wait for Run Magazine to come in the mail and then type in the programs that were printed in it to see what they did, right? That was not a fast way to learn stuff. So nowadays you can find all these resources, and I'll put a list of books that I like together and put them in the Slack so everyone can see it.
In the same kind of thing, is there any online classes that you took or that you know of that are solid, or YouTube channels that are like,
Sure.
hey, this one's great for that as well?
Yeah, I like Hacking with Swift. I like his online stuff. I like We Heart Swift is another good one. As far as YouTube channels, the content is dated but very good. There's an Apple Programming YouTube channel called Apple Programming. It's more advanced than the other stuff I just said, but it's good as well. There are big collections of Swift playgrounds on GitHub that you can get that have all kinds of ways to learn code. It's like, oh, I want to learn about SpriteKit. And so you can go get a SpriteKit playground that teaches you how to make games in SpriteKit and things like that. So there's a lot of really cool resources out there, and I'll put links to that stuff in there as well. So there's a big list of resources I think can help you get started. For people that want to do stuff that's harder, if you really want to get to the nitty gritty, learn a little assembly language. There's actually a book in the iTunes bookstore about doing Intel formatted ASM in Xcode. So it's got a template you can use, and then you can do assembly programming in Xcode. That's fun for reverse engineering stuff, right? Then you can get Hopper or run NM and dump out the assembly instructions for the app you're looking at, and you can it feels really great when you can look at that and figure out, oh, I know how that app works, even though I can't get to the source code. So that's fun stuff as well. More questions? We have 2 minutes to go. All right, in the back, right behind. If you can pass the cube back. Yay, someone
Hi.
threw it.
So I've been taking classes online to learn a little bit of Swift. I've never programmed before. And the advice that I keep seeing a lot is to practice as often as possible. But something that I struggle with is coming up with ideas for apps or ways to apply what I just learned. So do you have any advice for coming up with ways to practice or resources where we could find sample projects to sort of do on our own, see how far we can get?
Yeah, some of the sample projects, one of the things I like about the Hacking with Swift lessons is that they start with making actual apps that work, that do things. And on the Mac, one of the things I did a lot of was, can I replicate LS in Swift? Can I replicate curl in Objective-C, right? Take something that I know completely how it works and pick one option flag for it and build out one version of it. And then that works really well for working your way through that. The other thing to do is there's a type of tutorial called a code kata. Code katas are daily bite-sized challenges. I did one the other day for Swift. I did it in a playground. It was write a function that translates strings into Pig Latin, right? So move the first letter to the last, add AY, don't mess with the punctuation. And that was a real good exercise on how to manipulate strings. Still a little program when I was done. Took me half an hour, but I know more about strings because of it. So code katas are good too. And we're out of time now.